This looks like a neat question. So we are differentiating with respect to x a function u of x times root x, and we're told that this is true from 0 to a half. We're also told that when u is 4, x is 3 over 8. Well, first things first, let's differentiate it using the product rule. So we're going to get du by dx, x to the half, plus u times a half, x to the minus a half. And we can now set this equal, actually I don't want to rush it, also from above d by dx ux to the half equals du by dx times, what happens when you differentiate root x? It's going to be a half x to the minus a half again. Therefore, du by dx, x to the half, plus a half u x to the minus a half equals du by dx times a half x to the minus a half. I think it makes sense at this point to times through by root x essentially. So that means we're going to get du by dx times x plus a half u, because that will cancel out, equals du by dx times a half. And to be fair, I could also times through by 2. Get rid of these. Now if I rearrange this, I'm going to get du by dx and factorize that out. Subtract this from both sides. So it's going to be 2x minus 1, and then I'm going to get minus u over here. And we've got a differential equation essentially. So to deal with this, we need to integrate. However, we need to use separation of variables to be able to deal with this. So I'm going to divide through by u, and then divide through by 2x minus 1. Because there's a minus there, it's going to be 1 over 1 minus 2x. I can flip it round. If I integrate now with respect to x, by the chain rule, this is actually the same as du. And when we integrate 1 over u with respect to u, we're going to get ln u, technically in a modulus. And this one, well, I probably should have, no, that's okay, we're going to get a similar thing, aren't we, of course. So it's going to be ln 1 minus 2x as a modulus. If I differentiate this, I'll have to times by minus 2. So here I'm going to divide by minus 2 and get that plus c. Okay, before we do any more, should we substitute in the condition we have, or would it make sense to do that afterwards? I think let's bring it together first. So we can write down Right, what should I do? I can raise everything to the power of e. That's not a bad shout. So if I raise everything to the power e, I'm going to get u is equal to e to the minus a half ln 1 minus 2x plus c, which is e to the ln. If I bring this in, it's going to be 1 minus 2x to the minus a half. And then when we got the plus c, we can actually write that as e to the c. We can bring it down and call it something else, like d, for example. And then these cancel, so u is actually equal to d all over 1 minus 2x square rooted. And that has to be positive, so I don't need the modulus signs. I hope that makes sense that I can do that. Okay. Now finally, we've got when u is 4, x is 3 over 8. By the way, learn how to deal with this sort of thing. When you got logs and logs, yes, you can raise it to the power. I've basically raised everything to the power of e, which I'm allowed to do. I just have to raise the whole of the right-hand side to the power e. This became e to the power of this times e to the power c. I just then called, maybe I should have written that down, d equals e to the power c. And then because these cancelled, I was just left with this, which I then wrote as 1 over 1 minus 2x square rooted, but I still had to times by d. So we're going to get that 4 is equal to d over 1 minus, it's going to be 6 over 8 square rooted. That's going to give me 2 over 8 or a quarter. I'm square rooting a quarter. So d is going to be 4 times the square root of a quarter, which is simply a half. So I'm going to get 2. And finally, hence, u is equal to 2 over the square root of 1 minus 2x. All right, really nice question using these different aspects of differentiation and integration. I like it a lot.